Alright, welcome to video number 2. I'm going to have to move a little more quickly here to get everything done. So the next thing that you learned this year at the beginning was exponent laws. So these are, again, relatively easy. Here's the first law. So you can write that down. Probably a good thing to have. So basically a way of saying what that means is if you have two powers with the same base, so the bases being the same is pretty important, right? So these both need to be the same, a and a. If that's the case and you're multiplying them, then you take the exponents and add them together. Okay, so it's m plus n. So let's look at an example. So we have 4 to the 5, no sign shown, so it's assumed to be multiplication if there's no sign, times 4 to the 3. Bases match, that's fantastic. And we're going to add the exponent. So this is equivalent to 4 to the 5 plus 3, which is 4 to the exponent 8, right? And then you could type that in your calculator and actually get an answer for it. But that's the way you would simplify it using that exponent law. Same deal here, matches, bases match. So keep the base the same and add the exponents. 2 add 5, we get 3 to the exponent 7. So the next one is the quotient law, which has to do with when you divide matching bases. So to divide powers with the same base, keep the base the same and subtract the exponents. So this is the definition of the law. And then here are a couple examples. So bases match, we're dividing between. So in this case, we can subtract exponents, 6 minus 3, 4 to the 3, and again, we can actually evaluate that on the calculator. Over here, even though it's a more complicated exponent, it doesn't matter. I have matching bases, we're dividing between, so I can simply just subtract the exponent. It doesn't matter what they are, they can be as complicated as you want. I just know I'm going to be subtracting them. Right, so this would be 5x minus 3x is 2x. So that's the simplification of it. All right, moving on. The final law is called the power of a power law. And this is if you take an exponent and raise it to another exponent, it's the same as if you were to multiply them together. So example would be 2 to the 5 to the 3. So this is equivalent to 2 to the 5 times 3, which is 2 to the 15. And we could, again, evaluate that if asked to by the question. But that's the idea of the law. So putting it all together, here's a couple examples of multiple laws together. So a question like this one here, question A, there's two things happening. And for a question like this, you're going to want to simplify the numerator as much as you can, simplify the denominator as much as you can, and the last step should be to actually combine them, right? So actually do the division at the end. You should want to simplify everything you can in the numerator and then the denominator, and lastly combine them. So if we look at the numerator, this is matching bases, good to check that. There's multiplication between, so the rule says that I can add these together. 5 plus 3 is 8, and this is over m squared. Okay, now I have matching bases. There's a division between them, so I can subtract. That's 8 minus 2 is 6. Nice. All right, over here, x to the 12 divided by x to the 2 to the 5. So then last thing we should do is the division. So right here, I guess you can think of it as bedmess as well, right? So your exponents e will be before you do a division or multiplication. So exponents, so the power of a power should be done first. So here we have the power of a power, meaning we multiply these. 2 times 5 is 10. And then I can use the quotient law. Dividing means I subtract. 12 minus 10 is 2. We also did some algebra manipulations. I guess you guys did, I wasn't there. So that means stuff like adding and subtracting like terms. You can only add and subtract algebraic terms when they're like. So as an example, here are two groups of terms. So 3x squared, 4x squared, and negative 2x squared. These would be considered like terms. And they're considered like terms because of the exponent part. Right, so the part you're really only interested in here is this bit of it. So this part of it, the exponent part, has to be identical for it to be considered a like term. So they all have exactly x squared. It doesn't matter that they're, and this part of it's called the coefficient. It doesn't matter that their coefficients are all different. It's only the exponent part you're looking at in order for them to be like terms. So the second group that's below, these are not like terms. And it's trying to confuse you by all the coefficients being similar, 3 and negative 3. But because of the variable parts being different, right, this one's just an x, this one is an x squared, this one's an x cubed, they're not like terms. So the actual exponent on the variable must also be the same. You also need to know how to do the distributive property. So that's the idea that if you have a number being multiplied into a set of brackets where there's some operation like adding or subtracting, the idea is to distribute this number into both, right? So a times b and a times c, as shown right here. So example of that would be like these questions here. So the idea is to take this number in front and distribute it into every term inside the brackets. So first we would do 2 times 3x, which is 6x, and then 2 times 5, which is 10. And I can't simplify any farther because these are not like terms. So that is as simplified as it can get. Question B, again, I'm going to distribute. 1/2 times 6x is 3x, and 1/2 times 8 is 4. I can now drop the brackets because I've taken care of this number in front. And I'm going to work with the second one. This one's confusing a little bit because it looks like there's nothing in front of the brackets except there's kind of like this -1 hiding out here. And you're going to take the -1, and that's the thing you're going to distribute into the brackets. So -1 times 2x is -2x, and -1 times -3 is +3. So now our like terms are things, again, with the same variable part. So 3x is like with -2x, and +4 is like with +3. So the sign that's in front always stays connected to it. So in total, if we collect our like terms, 3x minus 2x is a single x. 4 and 3 makes 7, and that's as simplified as we get. Okay, and last example. Distribute inside. 3 times 2 is 6. So multiply the coefficients as well as the variable parts. X times x squared is x cubed. You add the exponents. So 1 and 2 is 3. And multiply over here. 3x times -4 is -12 x squared. These are not like terms, so that would also be done. Video 3 coming up.